Thank you, Professor Preeti, Professor Aprajita, and then I can see my other colleagues also. Okay, Dr. Vinod, then Dr. Gajendra, Raji, many more. So many of the familiar faces are around. Okay, and I will thank all of you that I have given talk on different occasions, but this is a novel cause for which you are working. That is, you are trying to penetrate to the different parts of South Asian region, so that we can reach to remote areas through this online uh, workshop. And I hope that they will attend all this workshop, and the speakers which you have arranged, to my knowledge, they are very good. Okay, so they'll be benefited. And the other reason is that by 2030, what is expected is there is minimum 25% increase in job in AI, ML, and data science, in comparison to 5% more requirement in other areas. So for participants, I think this is a golden opportunity. Try to understand its basics and implement also. Okay, so I have been given 1 hour time. So I will touch the basic components of AI and ML, and the rest basics will be taken care by my other colleagues. So I'm sharing my presentation with you. So is this screen visible to all of you?
Yes, sir.
Okay. So I'll first discuss very briefly about artificial intelligence. Then I'll be talking about what is machine learning. There are many techniques which you are going to learn, and there are many techniques which you will not be able to learn during this 1 week workshop. So I'll be touching on neural network, and then I'll be talking about another important topic where many of these applications are being developed based on deep learning models. Okay. So we say that necessity is mother of invention. So if you see how we have started using computers, so we broadly divide the use in the 4 different kind of processing. So first is data processing, then followed by information processing, then knowledge processing, followed by intelligent processing. So let us see actually what do you mean by this. Before that, can you see this picture? This is actually a computer. And the size of this computer, you can see, is maybe the bigger than the size of 10 by 10 bedroom. Okay. Because we were using at that moment of time vacuum tube technology. But now, the same thing we can do with a small computer, which we are having in our hand all the times. That is your mobile is also a kind of computer. Okay. So when we talk about initially, we were using computers for management of data. And we used to talk about this is your data processing. And what we used to do, we wish to manage records of one particular organization. While managing records, sometimes we need to search a particular record, or as some employee has joined the organization, so you have to insert a new record, or you have to delete some record, or you have to modify some records. So I think these were the primary uses of computers initially, and we were very happy that now we were doing this management of records more efficiently in comparison to what we used to do manually. But with time, then we all of us start thinking that how we can use computer for some other purpose. And then we started talking about information processing. So let's see how information processing is different from data processing. So say you want to, now this date is over, okay? So you want to predict what is the rainfall, what is the amount of rainfall on May 3, 2023. Let's say this. So you want to predict, it's not May 3, 2024. So at present, we don't have that data. So you cannot look in the database. But based on last few records, or let's say last 10 years records of rainfall distribution, it can be predicted what will be the amount of rainfall on May 3, 2024. So similarly, let's say you want to predict what will be the population of one particular country by 2025. So at present, that data is not available. So is it possible based on past records, we can predict? Similarly, can we predict GDP of a country in 2024, 2025? Can we predict price of a share? So all these data are not available, but all these can be predicted based on the past data. So how information processing is different from data processing? You have a set of data, and now you can infer from this data some new information, okay, or which you can predict a new information. Then you are talking about information processing. But I think we have not stopped here. Then we started talking about knowledge processing. So let's see how knowledge processing is different from information processing. So in our day-to-day life, when we go to market and purchase bread, quite often we purchase butter. So while we are, I think some of you have raised hands. Is there any problem? Hello? Hello, some of you have raised hand. I can see Komal, Ritu, Saksham, Akshita. These people have raised hand. What is the problem?
Sir?
Oh, slides are not moving.
Yes, sir. Yes, sir. Slides are not moving.
But in my case, it is moving. Oh, let me see. Anyhow, I'm starting once again, huh?
So now it is visible, sir.
Now it's visible? Okay.
Now it is visible.
Okay, it's visible. Okay. So now please confirm it whether it's moving or not. Is it moving now? Is it moving? Hello? Can you confirm?
You are in the slide number 7. Am I correct, sir?
At present, can you see slides on intelligent processing?
Knowledge processing we are seeing, sir.
Oh, I think, what is the reason? Okay, what I do, I'll again share, huh? Maybe, huh? So I'll stop sharing, again I'll share, huh?
Yes, sir.
Is it visible now?
Yes, sir. Is it visible?
Yeah. Can you see knowledge processing?
Knowledge processing. Yes.
Okay. And what about this? Is this picture is visible?
Knowledge processing is visible, sir.
No, after this picture is not visible?
No, sir. No, sir.
What's the problem? What is the reason? I cannot make out. What about this early history?
No, sir.
No.
No. Now is visible.
No, let me see once again. Okay. Now is it visible now?
Yes, sir, it is visible. Please make it full screen.
So is it full? Can you see this slide now moving?
Make it full screen. It is not moving, sir.
No. I am already in full screen mode.
No, but we are not. I mean, it is not in full screen mode on
No,
our
yes,
screen.
here I can see that I am in full screen mode. Okay, once again I will do it. What can be the problem? What about this now?
Yeah, it is now. It is visible. Can you change the slide so that we can see the other slides
What
are
about this?
visible? Yes.
Now, is this picture
Yeah.
visible?
Now it is. Yeah. Now it is visible.
Picture is visible.
Yeah, it is visible.
This new picture is also visible.
Yeah, it is visible.
Okay. Sorry for trouble. I don't know what is the reason. Okay. So, I was talking about information processing. Now I'll be explaining what is knowledge processing. So in our day-to-day life, when you go to the market, so when we purchase bread, quite often we purchase butter or jam. So similarly, when we purchase potato, most of the time while we purchase potato, we purchase either onion or potato. Similarly, when I purchase shirt for myself, most often I purchase trouser which is matching to my shirt. So these are the items which are purchased together most often. So I'm talking about a true story. There was a grocery shop in US and manager wanted to improve the sale of that particular shop. So he appointed one data analyst to analyze the transactions of last many years and find out which items are purchased together. But he wanted to know items which are purchased together, but it is not known to us. So after analysis of the transactions, data analysts informed that the persons who are buying diapers, they are buying beer also. So I'm talking about the spelling of beer is B-E-E-R. So it was very surprising that diapers are generally used by children, small children, while we go for when we go from one place to another. So we want that there's no trouble during the journey. So we tie around diapers. But beer is definitely not for small children. So how can these two items are purchased together? So after more analysis, it was found that these two items are purchased during weekends. So while diapers is for children, beers are consumed by elderly people. So on the basis of this new information, manager rearranged the shelf. Now he kept diapers and beer nearby on the shelves, and sale improved. So this is the power of data analysis. So what I'm saying that how knowledge processing is different from information processing. You have a huge data. From this huge data, you are inferring some data. You are taking out some information, but that information is novel, interesting, useful to the society, to the scientific community, to the business community. So any novel, interesting information which you are digging out from the data, we are talking about knowledge processing. So I think we have not stopped here. So now we started talking about intelligent processing. So what do you mean by intelligent processing? So say you think about you have a refrigerator in your house and you open the refrigerator and you find that milk is not there, vegetables are not there, or fruits are not there, and you become upset. So that you again go to the market and purchase those items. But now what you are talking about intelligent processing that there are sensors attached with the refrigerator, which keeps on recording the quantity of fruits, vegetables, or milk, or other necessary items. And if one particular item is not enough in quantity, directly the machine is placing order to the nearby grocery shop. But yes, but the bill will be paid by you. So now we have moved to the highest level of processing, where you want that the machine should also behave like human. And we are not talking about your automotive, now you have cars now which are available in India also, which has many features which are automatic. Means you need not chair gear, you need not chair you can say lock the doors. Okay, before you will start the car, the doors will be closed automatically, or gear will be changed according to the speed of the vehicle. So now you have driverless car also. So we are moving towards intelligent processing. And when you talk about the birth of this intelligent processing, I think that was we talking about artificial intelligence. So I'll be talking about what is artificial intelligence, but before that, let's talk about what is the difference between computer and humans. While you want to add two small numbers, we can add very fast. But the moment you have to add two big numbers, I think we may take a lot of time to add two numbers or to multiply two numbers. But the same thing, the computer can do very fast. But there are certain things which humans can do in much better way, while computers cannot do. But now the objective of your AI, or you talk about machine learning, is that in what way we can mimic humans. Means the way we can recognize, can we empower computers that they can also recognize like humans, they can take decisions like humans, they can behave like humans. Okay, so that's what we talk about your thinking machine. So when we talk about artificial intelligence, so what we can say about artificial intelligence is the study of computer systems that attempts to model, or that builds the model and apply the intelligence of the human mind, so that they can take decision like human, they can behave like human, okay, they can recognize like human. Okay, now when we talk about early history of AI, so there was a work by Alan Turing in 1950, and the basic question was, can machine think? And we talk in terms of that is Turing test. And according to this Turing test, what is your Turing test? Whether Turing test will fail or it will pass. It will depend upon if there is a human and which is there in a closed room, and he's interacting with a human and a computer. So while he is able to read messages from both human and computer, so he has to distinguish a particular text, whether this text is written by human or it is written by the computer. So if he is able to decide or distinguish this written text, that who is the author of this text, then it means he has passed this test. Okay. When you talk about early history of AI, I think we cannot forget John McCarthy. So he was the first person who has organized a workshop in 1956, and he coined the word for the first time, study of artificial intelligence. And after a few years, he was the one who has given the first programming language for artificial intelligence, and that goes by the name Lisp. Okay. So when we talk about the difference between artificial intelligence and machine learning, although we say machine learning is a subset of artificial intelligence. So artificial intelligence, you say, is a bigger set, and machine learning is a subset of artificial intelligence. So when you talk about artificial intelligence, we talk about it is a scientific field concerned with the development of algorithms that allows computers to learn without being explicitly programming. Okay, means you're not writing explicit programming for doing one particular task. Means if you can write algorithms so that computers can learn from the data, then we are talking about artificial intelligence. Machine learning is a branch of artificial intelligence, which focuses on a method that learn from data. So when we learn from the data, and then we make various kind of prediction on unseen data. So you can see from this model itself, let's say you have data, and from this data, you have learned the relationship between input and output. Okay, and then if you give new data, then you'll be able to predict. So let's say you pass on the data of last 10 years of rainfall distribution. Means when the temperature, pressure, humidity, wind velocity is one particular value, what is the amount of rainfall? So let's say you have various such records are available. So you learn the relationship between this input and an output. And the next time you are simply giving what is your pressure, temperature, your wind velocity, humidity, and then machine can predict what is the amount of rainfall. So when we are talking about machine learning, so let's see with the help of examples what we can do, which human can also do. So if we ask, what is there in this picture? So each one of us can tell what is there in this picture. We can say that there is a person riding motorbike. The way we can describe, similarly, now we have machine learning models where machine learning models can also describe the picture. Similarly, if today we can recognize voice of some well-known person, because we have already heard many times, let's say we have heard dialogues of Amitabh Bachchan many times. So now, if dialogue clip is available to us, audio clip is available. So by going through that audio clip without video content also, we can recognize. So the way we can recognize, now machine can also recognize such kind of audio. Similarly, the way we can recognize if you are given a text, whether it is a good text or bad text. So similarly, now we have machine learning algorithms which can recognize whether it is a good piece of text or bad piece of text. And one of the example is that all of us are using Gmail service or some other email service. So when mail comes to us, so mail is directed into inbox or spam based on the content of the mail. So if they find that the content is good enough, then mail is directed to inbox. If they find that it is a spam mail based on the content, then they send it to spam folder. So the way we can recognize whether they good content or bad content, similarly now machine can also recognize. So there are many examples where we are using machine learning. When you are talking about your face recognition systems, which we are using in many of the organizations, so we are using machine learning models. We are talking about there are many organizations which are recognizing authentic user based on fingerprint. So again, this is an example of machine learning. So these days you are analyzing one particular area by capturing a satellite image. So you have a satellite image without actually visiting the place, based on the texture, color, intensity of the image. Now you can talk about whether they can talk about that this is road, this is your green region, this is a habitat area, or this is a water body. or at this region there is a oil, just based on the texture, intensity, color, or different frequency bands. Okay. Now, as we have already talked about, the way we can describe all these images, now machine can also describe each one of the images. So only very recently I went to for regular checkup, and I got my ECG done, and along with the ECG pattern, there was one output was also there that your ECG is normal. So earlier we used to take by getting that ECG, we used to go to the doctor, and doctor used to look into the ECG pattern, and then doctor used to say whether your ECG is normal or abnormal. But now, along with the instrument, now you are embedding your machine learning component. It is analyzing that ECG pattern, and now that decision system is able to give you decision whether your ECG is normal or abnormal. Similarly, these days you find that there are a lot of your cameras are installed in market, or you're in railway station or airport, where you are watching the behavior of people. Okay, so means surveillance system. So you are capturing this data. At the same time, there is a machine learning component is sitting there, which is analyzing the behavior of these people. And if there is some unusual event or movement in one particular area, alarm is raised. Okay. So again, this is an example of machine learning. Now, many of the financial institutions, banks, they are using machine learning systems to decide whether they should give the loan to one particular person whose profile is available to them. Now, these days, many of us are using machine learning models for predicting the price of a share. So now, there are three different kinds of machine learning. One is your supervised learning, another is your unsupervised learning, and third is your reinforcement learning. And I was going through the schedule of the workshop, and I found that each one of these components will be discussed in detail. But I am just touching briefly what is supervised learning. So let's say you want to develop a machine doctor, where machine can tell whether you are healthy or not healthy. So at present, while you visit a doctor, so doctor note down some of the observations, and those observations are your height, weight, your pulse rate, your body temperature, and many more observations. And based on this, doctor tells whether you are healthy or not healthy. So now the question is, can we have a machine doctor where machine can take these inputs and tell whether you are healthy or not healthy? So I'm saying yes, this is possible. So to understand this, let's talk like this, that you are given data of persons in terms of only height and weight. So when I'm talking about this data, which is plus blue sign, so along x-axis, let's say this is height, and then along y-axis, you have weight. So when I talk about this sample, so I'm saying this is the height and this is the weight. And let's say you will tell to the machine that this person is healthy. With this height and this weight, this person is healthy. Similarly, this new record with this height and this weight, you are saying healthy. So, and similarly, there is another data with this height and this weight, you say that the person is not healthy. So you are showing many examples to the machine. You are showing some examples of healthy and some examples of not healthy. And then machine has to learn the relationship between height, weight, and output, that is the person is healthy or not healthy. So how machine can learn the relationship between this height, weight, and the output, that is whether the person is healthy or not healthy. So to explain this, let's say you talk about this is a new sample, and now if machine has to take a decision whether this example belongs to healthy category or not healthy category. So before machine will answer, if I ask any one of you that what will be the decision? So definitely most of you will say that this example belongs to healthy category. And what is the whole idea that is coming to your mind? That is, you can see that this example is very much similar to this example. So these two examples are very similar to each other. So this example is healthy. So this example should also be healthy. I think that logic must be coming to your mind. So the same logic which we are using can also be used by the machine. And actually we are using this algorithm as a machine learning algorithm, and name of this algorithm is nearest neighbor algorithm. In this, what we do for this new coming example, we find out distance from this new example with each training examples one by one. So if you have n training samples, then you will get n distances. And among this n distances, we can find out which training example is at nearest distance. So definitely you will find that this example is at the nearest distance from that data. And now, since this sample is very much similar to this test sample, so you can give the output, which is the output of this training example. And the output of this training example is your healthy. So the output of this test sample will also be healthy. Okay. So this is one of the basic machine learning algorithm, and name of this machine learning algorithm is nearest neighbor algorithm. In this, what you do, you are given a set of training examples, and you know the class label of each training examples. For a new test sample, you are going to compute distance from this test sample with each one of the training examples. So if there are n training examples, you'll have n distances. Among this n distances, you find out minimum distance. And if this is your minimum distance example, find out what is the class label associated with that. And the output of the test sample, you can predict same as the output of this nearest sample. Now, but what is the challenge? The challenge can be sometimes is, if this test sample is here, which just in between this plus sample and red sample, okay? Plus blue sample and red circle samples, which is lying in between this new test sample, okay? So then in that case, both the training examples will be at the same minimum distance. So then you will be confused whether the decision will be healthy or not healthy. So what we do in real life, when we have such kind of confusion, that one doctor is saying that you need surgery, other is saying that you don't require surgery, you can be treated with medicine, then what you do? You take the opinion of the third doctor. So the same you can do here, that instead of finding your nearest neighbor of this test sample, you may find 3 nearest sample of this test sample. Say if all the 3 nearest sample belongs to healthy, so decision will be healthy. If 2 of them are saying healthy, then also decision will be healthy, else decision will be unhealthy or not healthy. So then we coin the new algorithm, and that is your modification of nearest neighbor algorithm, and that is your k nearest neighbor algorithm, where you are saying k you must choose to be an odd number,
You choose k is equal to 3 or 5 or 7 or 9, and then you find out among this k whose majority is there, and based on the majority you take a decision. So similarly, there is another machine learning algorithm. Okay, in this, what is the idea? The idea is that you have these two class data, and the another way of solving the problem is that if you can find out decision boundary which can separate these two class of data. So can you see that this is a decision boundary which can separate these two class of data? Means above this decision boundary, the samples belongs to healthy category, and below this decision boundary, samples belongs to not healthy category. So if you can have some way by which you can find out this decision boundary for this particular problem, that this equation of this decision boundary can be equation of a straight line. And what is that? So if x1, x2 are two variables, the equation of this straight line can be given by w1 x1 plus w2 x2 plus b is equal to 0. So let's say there is some way by which you, from the data, you can find out w1, w2, and b. Then next time, if you are given a new sample, then you will simply check w1 x1 plus w2 x2 plus b. If this quantity is more than 0, you will say sample belongs to healthy category. If this lies below if it is less than 0, then you will say that sample is lying below this decision boundary. Then you say that the sample belongs to not healthy category. Okay, so there are many methods in machine learning to find out this decision boundary. One of the method is your linear discriminant analysis method. The another method is based on single perceptron. Then you have support vector machine. Then you have neural network models. Okay, so there are many ways by which you can find out this decision boundary. So when you talk about supervised learning techniques, so there are many kinds of supervised learning techniques which are broadly categorized into numerical classifier functions, parametric functions, non-parametric functions, symbolic functions, and aggregation learning. And within each one of these categories, there are many methods. So when you talk about classifier functions, you find one of the method is your linear classifier perceptron. Then you have logistic regression. Then you have support vector machine. Then you have multi-layer perceptron. Then in parametric functions, you have naive-based classifier. You have GDA. Then you have hidden Markov model. Then you have probabilistic graphical model. In non-parametric method, you have example of k-nearest neighbor. And similarly, there are other methods also. So I will touch upon the basics of multi-layer perceptron because I'm going to introduce basics of deep learning today. Although you will be learning in detail by the other colleagues who will be presenting in detail. So it is motivated by your brain, human brain, because you see that we talk about all of us are very intelligent. And we are able to take intelligent decisions because of the working of our brain. And brain is consist of billions of neurons. Okay, and they interact, they exchange messages from each other, and then they are able to take a final decision, or they are able to analyze a situation. Okay, or they are able to recognize something, or they are able to understand something. Okay. So to understand deep learning, I'm just introducing basics of multi-layer perceptron. So in this multi-layer perceptron, you have basically, we talk about that it is your acyclic directed graph. We say acyclic directed weighted graph. Why we say acyclic, I'm going to explain you. But before that, I'm going to talk about that when you talk about this architecture, you are saying you have, it is consist of a set of neurons which are categorized into three kinds of neurons. One is your input layer neurons, then you have hidden layer neurons, then you have output layer neurons. Then every neuron of input layer is connected to every neuron of hidden layer. And similarly, every neuron of hidden layer is connected to every neuron of output layer. And since there is no way by which you start from one neuron and you come back to that neuron, so there is no cycle is involved. So that's why we say it is a cyclic weighted directed graph. So assuming that this is your node I of input layer and this is your node J of the hidden layer, and this is your kth node of output layer, we assume that the weight between these two layers is given by Wji. And similarly, the jth node of this hidden layer and kth node of this output layer is connected by this edge with the weight Wkj. So while we know input and we know output, what we do in multi-layer perceptron is that we want to find out weights in such a way so that it establishes a relationship between input and output. Okay. So, so how we learn this relation weights? So what we do, so if you give inputs, let's say x1, x2, x3, xd, and these are the weights. So we compute what is the net input reaching to this neuron, and this can be computed as x1 into this weight plus x2 into this weight plus I into this weight plus xd into this weight. And then there is some bias, which we say there is always a constant input which is coming to this neuron all the time. And let's say we talk about this weight, this bias is Wj0. So in this way, we'll be able to compute what is the net input which is reaching to this neuron, jth neuron. Similarly, we'll be able to find out what is the net input reaching to each one of this neuron. So when there is an input coming to a neuron, what will be the output? So the output of the neuron will depend upon what is the activation function you use. Okay. So let's say if we use some function f. So if net j is the net input reaching to the neuron, so I say f net j is the output coming from this neuron. And let's say we name this as yj. So I'm saying that y1, y2, y3, yj are the net output coming from these neurons at the hidden layer. They will go as an input. Similarly, we can compute what is the net input reaching to this neuron. Let's say this input which is reaching to this neuron is given by net k. We can compute what is the output coming out from this net k. So let's say this from kth node of output layer, zk is the output coming out from this neuron. So we are giving input x1, x2, x3, xd, and we are observing output, that is your z1, z2, z3, zk. But the actual output is your t1, t2, t3, tk for the same input. So then there will be difference. So actual output you expect for the input is your t1, t2, t3, tk, and observe output is z1, z2, z3, zk. So you can find out the error. So what is the net amount of error coming out at the output layer? And what you would like? You would like that this error should be as minimum as possible. Then only you'll be able to get the output for a given input, desired output for a given input. So once you know this error, your objective will be to minimize the error. So then there is a popular method in mathematics which we talk about, gradient descent method. So gradient descent method allows you to find out the direction that along this direction, if you move, error will decrease. And that size by the delta W. Delta W is the size by which you change the weight W. So if you change W by delta W, then this method tells you that along this direction, there is a high probability that error will decrease. And this can be given by minus eta del J by del W. I will not go into details of the mathematics. Okay. So I'm saying there is a way by which you can decrease the error, you can minimize the error. So in this multi-layer perceptron, initially you were not knowing any weights. So what this algorithm suggests, you start with any random weights. You are given training examples. You know for a given input what is the expected output, what should be the output of the machine. So now you give the input, you compute the output, you compute what is the error, and if the error is large, then you change the weights. So how you change the weight? You can change the weights W by delta W, and this delta W is given by minus eta del J by del W. Okay, so you can find out that if you want to change WKJ, if there is an error, by how much amount you should change, then this is by delta WKJ. And what is your delta WKJ? It is minus eta del J by del WKJ. Similarly, by how much amount you should change WJI? You'll change by delta WJI, and this delta WJI will be equal to minus eta del J by del WJI. And if you keep on doing this, after few iterations, you will get a set of weights for which you'll find the error is not much. And once you're able to have these weights, then you can pass on your new input vector, and then you can predict what will be the output. So while I was talking about this, these many methods, there are many machine learning methods. There is another important theorem in machine learning which talks about no free lunch theorem. And in nutshell, what I want to say is there are many machine learning, supervised learning models have been suggested. But according to this, there is no single machine learning model which is best suited for all problems. Okay. And that's why, because the generalization performance of no machine learning model is best for all kinds of problems. Okay, and that's why we keep on developing newer machine learning algorithm, so that maybe in future we'll be able to find out such a machine learning algorithm whose generalization performance is very good. Okay, then so then there is another important concept to understand deep learning models, and that is universal approximators. So let's see first what is universal approximator. This tells that if you use only one hidden layer with sufficient large number of neurons, then you can learn any relationship between input and output. Okay, so if you have neural network with one hidden layer but sufficiently large number of nodes at the this hidden layer, then you can learn relationship between any input and output. But what is the problem? The problem is that if you keep very large number of neurons at the hidden layer, then the number of connections which you are going to, if the number of neurons at this layer is very large, the number of weights which are there between input layer and hidden layer and output layer will be too many. And then you will need more time to learn. And then you also need more number of training examples to learn the relationship between input and output. Then what is the way to handle this problem? So then we found another research work which talks about shallow versus deep architecture. And what it suggests is that instead of one hidden layer, if you choose more than one hidden layer, then the number of neurons which you require at these hidden layers will be less. And so the number of connections will be less, but the power of this will be equivalent to even with one hidden layer. So what do you mean by this is that if you have more number of hidden layers, you will be requiring lesser number of connections, okay, and then you will be able to learn this neural network very fast. So that is the power of deep architecture versus shallow architecture. So I am talking about this. That is, in between input layer and output layer, you can have many hidden layers. But even though this research work was available prior to 2005, in spite of that, none of us has ever used a multi-layer perceptron with more than 2 hidden layers. Then what was the reason? So the reason was that when we have more number of hidden layers, then it suffers from vanishing gradient problem. What do you mean by vanishing gradient problem? I'll explain. That is, we are giving an input, you are observing the output, then according to the theory, we can change the weights of this network. So how will change the weights? First we'll change the weights here, then we'll change the weights here, then we'll change the weights here, and then we'll change the weight here. Then again we'll rerun, and this will repeat many times, and then we'll be able to learn the relationship between input and output. But while we are changing the weights in this way, as per you can say derivation, it can be seen that the change in the weight here is a function of change in the weight here. And similarly, change in weight here is function of change in weight here. And similarly, change in weight here is a function of change in weight here. So if your delta W change here, let's say maximum change is 10 raised to a -1, then the order of maximum change in the weight here may be 10 raised to a -2, and here -3, -4, -5. So if you have more number of hidden layers, let's say if K layers are there, then the change here can be of 10 raised to a -K. So if K is very large, then it is as good as 0. So this was the problem. And that was the reason that we were not able to use the back propagation algorithm for implementing more than 2 hidden layers. But then after 2005, many research has taken place where they have suggested way out to develop deep architecture and you can say avoid the problem of vanishing gradient or because of computational load, and now you have more number of samples are also available. That is the other reason also that we are able to develop deep architecture. So according to your MIT Technological Review, which was published in 2013, the 10 breakthrough across all science and technology, if when they have gone through, they found that deep learning is one of them. So now you can see the importance of this work now also, because every now and then we are finding there are so many applications which are coming up, which are using your machine learning, deep learning architecture. Okay, so I will discuss very briefly about your deep learning architecture. So what is the solution? So that we can avoid vanishing gradient problem. So one possibility is that using autoencoder scheme. In this autoencoder scheme, what was suggested is that I will not learn weights all at once, but I'll use the principle of divide, conquer, and combine. Because if you have a complex problem, don't solve that complex problem at one go. You can think of dividing that complex problem into many small sub-problems, solve those small sub-problems, and then you can combine the solution of those big problems, sub-problems, to give the solution of that big complex problem. So same can be thought for solving this also, that we are going to learn weights first between these two layers. We'll not bother about weights of these other layers. After learning weights between these two layers, then we will learn weights between these two. Then between these two, then between these two, and then between these two. So since it does not involve multiple layers, so it will not suffer from vanishing gradient problem. But the question is how to find out weights between these two layers. So then this is your problem. So we can assume like this, that this is your input x1, x2, x3, and this is your hidden layer, and these are the weights we want to know. But at present, we don't know how to find out these weights. So there are many methods. I'm discussing one of them. So we can find out these weights by this method, that let's put one layer, and now we connect each node of this layer with each node of this layers, and then we, for a given input x1, x2, x3, we expect the output will also be x1, x2, x3. So now for every input, we want that there will be same output. So we can use the backpropagation algorithm to find out these weights. And once we know these weights, we can forego these weights, so that in the process we are able to learn weights between these two layers. And once we know weights between these two layers, we can compute what is the output coming out from each one of these neurons, and then it can be fed to the second layer, and we can use similarly the weights between the next two layers. So why we are naming this as autoencoder? We are naming this as autoencoder because you are encoding this input into some another form with the help of these weights. But for this, you have used that the output will be same as input. So you are encoding in such a way that for given input, the output should also be same. That's why the name of this scheme is said to be your autoencoder scheme. So deeper networks performs better than shallow networks. Okay, it has been found empirically for many problems. Okay, but it has also been found that if you keep on increasing the your layers, hidden layers, up to a particular extent, it will increase the performance. And beyond that, if you increase the number of layers, then the performance may degrade or the performance will remain the same. So it has to be, you have to carefully design that how many hidden layers you should choose, so that you are not using unnecessary resources. So if I have to briefly summarize, what is the difference between machine learning and deep learning? So in conventional machine learning, from the data, first of all, we used to represent the data in terms of a relevant set of features. Let's understand with the help of examples. Say we have to develop a machine which can distinguish a mango from apple. So how can you distinguish mango from apple? So you know that mango can be differentiated with apple in terms of color, in terms of shape, in terms of hardness, in terms of texture. So to describe any fruit, we can use these features. Okay, so there are many methods we use to extract features from the data. So in your traditional machine learning model, so for a given data, we employ different kind of feature extraction methods to represent data in terms of a relevant set of features. And after learning those relevant features, then we used to use some predictive model like support vector machine, neural network, or logistic regression, or decision tree. Okay. So in traditional machine learning, your feature extraction used to be one of the very important component. But when we talk about deep learning models, which we will see, that since we are using many layers, so among these layers, initial few layers does the job of feature learning, and the later few layers does the job of predictions. But we are not learning by few layers, features separately. This is a part of the system. While we are learning the relationship between input and output, this is your embedded feature learning is embedded component. So it is not a separate component, but we can interpret, we can think like this. Okay, so your feature learning and prediction, these are embedded together. So now in deep learning models, even from the raw data, we can learn the relationship between input and output. And in image applications area, in videos, in NLP, in other signal processing, we are using deep learning quite a lot, where we are learning from the raw data. So again, I have explained this difference between machine learning and deep learning with the help of a picture. So if you initially to describe a car, we represent a car in terms of a set of features. Those features can be your wheels, that it has your steer, and many more components which are there as a component of car. So we describe car in terms of its components. So that will be a feature extraction. And once we describe the car in terms of those features, then using those features, we learn the relationship whether a particular object is a car or not a car. But in deep learning, you can simply take a photograph of your different pictures, or you can take videos of different objects, and then this data can be utilized for learning both features and predictive models to decide whether the given object is car or not a car. Convolutional neural network is one of the well-known and widely used deep learning models, and it is more suitable for images, although it has been extended for videos and for audios and different medical data. Okay, but time does not permit me to discuss all this, and I have seen that there is a already a scheduled talk on convolutional neural network, so I'll stop it here. Okay, so I keep some time for some question answers. Okay.
So please feel free to ask question if you have any. So, I mean,
No question.
you have taken up a subject, I mean, in the beginning itself in such an interesting way that, I mean, I feel that the participants must be feeling inquisitive right now to learn so many things in this program. So you have actually set the stage for this program. So thank you so much, sir, for your wonderful talk, as it was expected. Thank you for being here in this program to bless all these participants. And we sincerely hope that with this enlightening lecture on introduction of AI and ML, many of them will do good in this area. Thank you. Thank you so much, sir.
Thank you. Thank you for giving me opportunity. Thank you.
Excuse me, sir.
Yes,
Yeah.
yes.
So, yeah.
So this is Yasha from Sikkim Manipal Institute of Technology.
Okay.
So the way you described vanishing gradient problem was that basically as there are more layers that we use, the neural networks get more complex, and hence there is a loss of function that makes it.
I think while I have not shown the derivation part, okay, because in such a short time it was not possible. But while if you go through the theory of this multi-layer perceptron, what you will find will be that is you compute change in weight here. By how much amount I should change weight here? Okay, can you see this? Similarly, by how much amount I should change weight here? Okay, so after computing error, I change weight in the backward direction. And mathematically, it can be shown that change in the weight here is a function of change in weight here.
Okay, sir.
And similarly, change in weight here is a function of change in weight here.
Okay, sir.
Okay. So I told that if let's assume that the change in weight here is of order 10 raised to the minus 1, maximum change.
Yes, sir.
Then maximum change here, because of multiplicative factor 10 raised to the minus 1 into 10 raised to the minus 1, it will become what? 10 raised to the minus
Minus 2,
2.
sir.
And here it will become minus 3,
Yes,
minus
sir.
4, minus 5. So more will be the number of layers. Okay. So in
Yes,
that
sir.
case, if you have k hidden layers, then it will be 10 raised to minus k.
Yes, sir.
So if k is very large, then it is as good as 0.
Yes, sir.
Okay.
Yes,
So
sir.
if you
Thanks, sir.
use existing backpropagation algorithm for updating the weights, then this will create a problem.
Yes, sir. Definitely.
And this we say, so there are two ways: vanishing gradient and vanishing. Then you say gradient, vanishing gradient, and then your gradient exploding also. It can be other way around also. Okay.
Okay,
So,
sir.
but one of the, so both are not advisable. Okay.
Okay, sir.
So
Thank you so much, sir.
don't worry, Yash. We will, I mean, sir, although sir has explained it very clearly, but we will have explicit sessions on it. So have
Okay.
some wait.
Thank
This
you.
is just an introductory talk. So we'll
Yes,
take
sir.
up all these backpropagation, these proofs and all, everything in detail. Don't worry. So we have 2 sessions. We have kept 2 sessions for all these things. Yeah. Before
Thank you, ma'am.
before you will go to see it.
Thank you.
So thank you. Thank you so much, sir.
Okay.
Once
Thank
again.
you. Thank
So
you.
we
Thank you
will, all these lectures are streamlined and they are available on YouTube. You can see them at any point of time. And we will share you a Drive link where we will share you all the material related with your lab. So Neha, can you share the link of Drive with the participants so that they may be ready for the lab session, which we are going to have, after this break?
Sure, ma'am.
Thank you,
Okay.
sir.
Thank you. Thank you.
Thank you so much.